Hey Halloweeners, so today in our class we went over the central angle being equal to the arc that it intersects, so theta is equal to BC. And we also went over that the inscribed angle, angle D, is equal to half of that arc BC. But not a lot of you seem to agree with that last fact. We were very solid on this, but not everyone really agreed with that. So I figured I'd do a geometric proof using concepts that we already understand to kind of show that to you. On the right here, you'll see most of that proof. I've hidden the conclusion until the end. You have to watch to the end to get that. But you can copy this down as I talk. So let's take a look at what we know. We know O is the center of the circle. That was given to us. We know this is the central angle, as we've said. We know that it's equal to the arc BC. Okay, all that is given. What are we trying to prove? Well, we're trying to prove that D is equal to half that arc. So let's look at the diagram, see what we can pull out, see what we know. Oh, almost showed you that. So we know, since O is the radius, we know that AO, or O is the center, we know that AO, OC, and BO are all radii. That's these lines here. 3 radii. So that means that they're all equal, right? Pretend these are congruent symbols. Well, if they're equal, that means that this triangle here will then be isosceles. So I'll mark that on our lines. That's equal, that's equal. And what do we know about isosceles triangle? The angles opposite the sides that are equal are also equal. So I'll mark that in there. And we have that there. Angle D is equal to angle F by the properties of isosceles triangles. What else do we know? Well, we know these two, since they make up the line, they must be supplementary angles. So that means they're equal to 180. I like to rearrange that real quickly here for a fact we're going to use later. That means if we subtract theta from this side, we get angle E is equal to 180 minus theta. That'll come in handy later. Well, what do we know about triangles? We know all 3 angles add up to 180, so that means D, E, and F will be 180 degrees total. And some more algebra. If we add D and F, it would be the same thing as multiplying one of them by 2 because they're equal. So they're equal parts, so they'd make an equal whole. Well, let's do a little bit more algebra. We'll start with D, E, and F equaling 180. And then we went back to, what's that line doing there? We went back to our definition of D, E, and F. We said E is equal to 180 minus theta. So here we replaced E with 180 minus theta. Alright, well, let's do some more algebra. If we subtract 180 from both sides, we'd get 0 on the right. So let's add theta, and we get D plus F equals theta. Well, here's where that trick comes in. D plus F is equal to 2 plus F, or excuse me, 2 times F, or 2 times D. So we'll look over here. D is that inscribed angle, right? We double it, and we'd get an angle equal to theta, our central angle, which was equal to BC. Okay, why not we divide that by 2? And we'll get just that angle D alone equals theta over 2. And well, since theta was equal to BC, since we've now got half of theta, which is equal to D, we've shown that the inscribed angle is equal to half the central angle is equal to half BC, which is what we were trying to prove at the start. I hope this quick proof has explained to you guys and made it a little bit more clear that the inscribed angle is half of the arc BC. Have a happy Halloween!